Okay, so let's continue with our GCD conversation. So let's think about if we have GCD of n comma 1, what does that equal? Where n is a non-zero integer. Well, from before, and actually if you remember, which don't worry, you don't need to you don't need to memorize the numbers of my examples from the last video, but we know that GCD of n comma 1 needs to be bigger than or equal to 1, and this was by example 2, and GCD of n comma 1 has to be less than or equal to 1 by example 4, because 1 is going to be less than or equal to the absolute value of n, since n is not 0. All right, so awesome. Well, what does that mean to be bigger than or equal to and less than or equal to? Well, there's no other option but to be equal to it. So GCD of n comma 1 equals 1. Amazing. Okay, so now we know whenever there's a 1 in either the when we're trying to find the greatest common divisor of some number and then 1, it's always going to be 1. Okay? Similarly, we can think about let's say P and Q be primes such that their absolute values are not equal. So they're not equal and their negatives are not, there's like no combination where they're equal. Well, then what's our GCD of P comma Q going to be? Well, divisors of P are 1 and P. Well, we could say absolute value. Let's say that P is well, let's just do that. Yeah. All right, divisors of Q are positive. Positive divisors of Q. 1 comma absolute value of Q. Whatever that may be. Well, we have 1 in common per usual, but we just said that these are not equal. So 1 is their greatest common divisor. In fact, we can say, so let's say that same P and Q as before, where M and N are positive, or at least non-negative integers. But if they are equal to 0, then we just refer to our example above and it doesn't really matter, because remember, any integer to the 0th power is 1. Okay. So this thing, well, what are our positive divisors? So let's here, let P and Q be positive primes. Okay. All right, so then our divisors of P to the n, well, guess who those are? That's 1, that's P squared, dot, 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 P to the n. So remember that dot, dot, dot just means we're continuing the pattern. So it might be that n does equal 2, so actually it really just stops here, but we're just writing it more in generic terms. Okay, so divisors of Q, Q to the m. Okay, well, same deal. Okay, but if we still have P is not equal to Q, well, then none of these are going to end up adding up together. right? Because they're primes. So remember, okay, then K divides L or K divides Z. Okay, so but this is something very specific about dividing by a prime number. Okay, so for example, if we were to claim that P does divide Q to the M, maybe, who knows, then P divides Q or P divides Q to the M minus 1. Well, maybe you say, okay, well, Danica, maybe it's that thing. Okay, well, now by induction, P divides Q to the M minus 2 or P divides Q, and we're going to keep whittling this down until we have, so by induction, we keep whittling this down until we have P divides Q or P divides Q to the M minus 1, right? Yeah. So now, what does that say? That means P divides Q or P divides Q. So one of those things has to be true. Okay? All right. So that's like an induction thing, which just says that none of these are going to end up being equal to each other because of this primeness that we have. So what do we get? Our GCD of P to the N, comma, Q to the M equals 1. Okay? So don't worry, you don't have to memorize like every single moving part I have in here. But it is chock full of some very interesting and useful facts that you can use, and also a use of induction within. There we go, that's probably a better way to write it. It's just all this then. Maybe I'll move this over. Okay, fabulous. Okay, there was something else I was thinking about talking about. What was it? P to the N, Q to the M. Oh no, I think that was it. Yeah. Oh yes, no, I do have another one. Okay, so let's say N be some non-zero integer. Actually, let's use K. And N integer such that N. So M and N integers such that N bigger than 0 and M bigger than 0. Okay. So then GCD of K to the N, comma K to the M, well, who in the heck is that going to be? Well, it's going to be whoever's bigger. Is it N or M? Who's bigger? Okay. Well, we don't know. Sorry. Let's say such that N bigger than M. How about that? Then it's going to be absolute value of K to the N. Oops, K to the M. Oh yeah. Because, so, all right. Sorry, I'm not explaining this very well. Divisors of K to the N. So we have 1. We have absolute value of K. We have K squared. So notice I didn't do absolute value because it doesn't matter. So N is bigger, right? Yep. Okay, so then K, absolute value of K to the M is somewhere in here. And then we keep going, and then we have absolute value of K to the M. So divisors of K to the M, well, that stops a little earlier, doesn't it? That stops right here. So they have this in common, they have this in common, they have this in common, all these in common. But most importantly, they have that in common. That's going to be the biggest out of all of them. Okay? All right. Okay, so let's try an actual proof with GCD in it, because we've done a bunch of examples. So now let's actually do something. So let A and B be even integers that are non-zero. prove that GCD of A and B is also even. Okay. So if we start with our proof, you know, I always really like starting with definitions of things. So for A and B to be even non-zero integers, then what needs to be true about them? Okay. Since A, B even, then there exists some, let's say K and L in the integers such that A equals 2K and B equals 2L. And let's specify maybe that L and K are both not zero. Okay, all right, awesome. So, all right, well, how should we continue this? So we want to show that GCD of AB is even. Well, why don't we start by saying let the GCD of A comma B equal D. Okay, so we don't know who D is. We just know it's going to be an integer. Okay, well, maybe let's do some exploring about D. So since 2 divides A and 2 divides B, then D is at least 2. Okay, well that's nice. But that doesn't necessarily mean, like, why couldn't D be 3 or something? So you might be thinking in your head that you understand why this has to be true, but we still need to prove it. Okay, so maybe let's talk about what if D was not even. So maybe let's do it by way of contradiction. Okay, so we're going to assume that D is odd. Okay, since D is the greatest common divisor of A and B, then D divides both of them. D divides A and D divides B. Okay, cool. Well, maybe I jumped the gun a little bit earlier with already using two of our go-to letters, K and L, but that's okay. So what does it mean for D divide A? That means that there exists some, maybe we'll do N and M, such that D times N equals A and D times M equals B. Okay, so maybe this is helpful, maybe it's not. Well, we need to think about what must M and N be. So if we have odd times something equals even, what must this something be? Well, if it's odd, we'll still get an odd thing. Odd times odd is odd. So it needs to be even. So N and M must be even. Well, what does that mean for N and M to be even? Then there exists, oh man, we're running out, aren't we? Why don't we use X and Y? No, we have a lot of letters left, but just not a lot of them are very nice looking. Like O, we would never want to use the letter O. Okay, so such that N equals 2X and M equals 2Y. All right, craziness, right? Well, let's plug that back in to what we have above. So then we have that D times 2X equals A and D times 2Y equals B. All right, well, why is this a problem? This is a problem because 2D divides A and 2D divides B. How crazy is that? And so why is this a problem? Well, we claimed that D was our greatest common divisor, but we just found one that's bigger because remember, D is positive, is not 0 or negative. So since 2D bigger than D strictly, then contradiction, since we claimed D was the GCD. Therefore, D must be even. Woohoo! Okay, so the thing I said in the beginning, that wasn't very helpful, but we didn't know it at the time, and it's okay. You know, it's okay to have things that are true or correct, but that are maybe not very helpful. That happens to a lot of people a lot of the time. Alright, well that's the end of this video. Hope you have a good one. Bye-bye.